Now, as more and more internet service provider upgrades to IPv6, we start getting pockets of IPv6 network on the internet, but still many service providers are still using IPv4. So how can these pockets of IPv6 address connect to the other pockets of IPv6 address via the IPv4 network here? The solution is what we call IPv6 tunneling. The idea simply is to encapsulate the IPv6 address data packet with a corresponding IPv4 address so that it can be routed through the IPv4 network. And of course, when it reaches the other side, the IPv4 headers are removed so that the IPv6 address the IPv6 data packet can continue to be routed through the IPv6 network. So in order to do IPv6 tunneling, the gateway routers, the routers that are connected between the IPv6 and IPv4 network, must be running in dual stack. Basically, it means it must understand IPv4 as well as IPv6 protocol. Now, you have your pockets of IPv6 address. So how do you know what next hop IPv4 address to go to in order to reach this IPv6 address? Now don't forget, you have another pocket of IPv6 address here, and how do you know what appropriate IPv4 address to use to reach this pocket of IPv6 address? So when IPv6 tunneling was first introduced, we have to manually remember what is the corresponding next hop, what is the corresponding IPv4 address associated with this pocket of IPv6 address. Now, manually trying to remember which IPv6 address is associated with which IPv4 gateway router presents a scalability problem. As more and more pockets of IPv6 comes up on the internet, you as an internet service provider would have to manually remember more and more next hop IPv4 addresses. So this one becomes a scalability nightmare. So in order to solve this IPv6 tunneling concern, the IPv6 engineer came up with the idea of dynamic IPv6 tunneling, whereby we have protocols like 6 to 4 isotype. So all this allows us to manually learn what is the corresponding IPv4 address, gateway address associated with different IPv6 addresses. Now, this is how you configure an IPv6 on the Cisco router. To do so, the first thing that you have to do is enable IPv6 unicast-routing at the config prompt. Then simply you go to the respective interface, such as interface FA0, and assign an IPv6 address to the interface using the syntax IPv6 address. Now, instead of assigning the entire IPv6 address, we can use the EUI solution, whereby part of the IPv6 address is automatically filled in with the interface MAC address, so that we don't have to plan an entire IPv6 address. We just have to plan the network component, okay, the prefix, okay. So this is equivalent to IPv4, the network component. So the host component, okay, will be filled in by incorporating the MAC address of the interface. So we use this command EUI-64. So you just have to specify the prefix using EUI-64. The host component will be filled in with the interface MAC address. Now this is an example of how the configuration is done. To configure IPv6 address on the Cisco router, we simply go to the global mode and configure IPv6 unicast-routing, because IPv6 routing by default is disabled. So once this IPv6 unicast routing feature is enabled, we can proceed to assign IPv6 address on the respective interface. So in this example, we are going to assign an IPv6 address on Ethernet 0. Now, as we have learned, so instead of having to plan an entire IPv6 address, we just have to specify the prefix, IPv6 prefix, and finish off with this command EUI-64, whereby the host component, the host component will be filled in using the MAC address of the interface. So as a quick recap, to enable IPv6 addressing and routing on the Cisco router, we have to first enable the command IPv6 unicast-routing. This will enable the IPv6 services to be enabled on the Cisco routers. Then we proceed to assign IPv6 addresses on the respective interface with the help of EUI-64 if we choose to do so. Remember, the EUI-64 basically allows us to use the interface MAC address to fill in the host component of the IPv6 address, so that we don't have to plan an entire IPv6 address. Now, after the IPv6 address has been enabled on the respective interfaces, we can enable IPv6 routing. So in this example, we are doing IPv6 RIP-NG to allow router X and router Y to exchange IPv6 routing information. So to do so, we simply use the command IPv6 router RIP followed by a name, in this case RTO0, and then we simply go to the respective interfaces and say IPv6 RIP RTO enable. Likewise, at the other router, we enable router RIP using the command IPv6 router RIP RTO, and then at the respective interface we enable the RIP function IPv6 RIP RTO enable, IPv6 RIP RTO enable on the respective interfaces. Now in IPv6 routing configuration, we do not have a network command. We simply enable the respective interface to run RIP in this example by enabling the command on the RIP command, the routing command, in this case RIP, on the respective interfaces. Now, after we have enabled the router RIP next generation, we can use the command show IPv6 RIP or show IPv6 route RIP to see the routes learned via the RIP routing process.